what are temporary works? The best place to look is BS 5975 2019, clause 5.1.1.1. I'm not going to read out that description from 5975 because it's quite word heavy, and it's basically one massive sentence from here to here, which is not ideal, but it basically says almost everything is temporary works when you read that. Now, if you go back to BS 5975 2008, that was the original definition, which is actually simpler. The new definition and lists that's within BS 5975 2019 encompasses a lot more, I would say, than previously was clear within 5975 2008. But we've got these words, but what does that mean in reality? What are temporary works? What things do we need to consider as temporary works engineers, or indeed site engineers, project managers, agents running jobs? So we'll just go through a few pictures here and identify temporary works. Firstly, we've got hoarding, nice and simple. Gates, piling platforms or working platforms. Temporary stockpiles, it's probably a bit overkill for this, but where you get larger scale stockpiles, it can often be a consideration. Assessment of existing or remaining structures. Moving on to this one here, you've got hoardings again, you've got basement wall, existing basement wall in the temporary condition. You've got propping, you've got loadings applied to the structure in temporary condition, you've got tower cranes, you've got access, formwork, false work, all sorts of things. This here is a bridge replacement scheme up Holloway, we did with Hopteeth. So you've got crane position, including an assessment of existing structures. You've got rebar stability, so assessment of the rebar cage in the temporary condition when it's been transported to site, when it's been lifted with the crane into position. You've got temporary stability of the bridge itself when the bridge deck was demolished. You've got temporary earthworks stability here. You've got a temporary access deck that you can't really see in there. You've got assessment of the existing structure in temporary conditions here, where you've got the wing wall with concrete pressures when you form this part of the abutment here. So there's lots of things that become temporary works. Obviously, the level of complexity determines how much attention you need to pay to them. Another one here, so this is again Upper Holloway, at a slightly different earlier phase of the works, where you've got bridge beams going in, so there's the temporary stability of those, not necessarily these beams, but the edge beams themselves, which often come in with the parapets precast, and there's quite regularly stability issues with those unless they're propped. Again, you've got propping of the, or not propping, you've got stability of the abutments in a temporary condition. This bridge, which is typical of some, the deck actually, or the original deck actually formed a prop between the two abutments. That was replaced in the temporary condition by a working platform that we built in there. Then we come on to the demolition side of things. So this here is Scunthorpe, a blowdown. We weren't the designers on this, we were the Cat 3 checkers. So that was checking to make sure that the pre-weakening was done properly and the design was adequate for the structure in a temporary condition. When you're pre-weakening a structure, it has to stand in the temporary condition, i.e. you have to look at the wind forecast and make sure that it's acceptable before you do the final cuts. But the structure could be standing for a couple of days in the partially pre-weakening condition until the final cuts are made on the day of the final blowdown. So all these things have to be considered as temporary works. We come on to some more interesting jobs that we've done. So this one here is, this is actually inside Birmingham New Street Station. For those of you that went to the old station, you will remember it was quite a dark, gloomy site, whereas now it is a very light, airy. It's quite an improvement to the station, I think. One of the first phases was the removal of one of the slab levels within the structure. The way that was done was quite unique. These crane rails, large crane rails which we designed, were slid into the structure and these gantry trains were put up, and then the structure was cut into pieces and wheeled out the far end of the structure straight onto the back of the lorries. So not many metres below this is the live railway line. And the reason it had to be done like this is because the plant loadings, we couldn't get any real plant loadings on there to undertake traditional demolition. So quite an innovative solution was developed in conjunction with Coleman Demolition. We hope to feature this as a case study in coming weeks. Again, this is another sort of interesting scheme we get involved with. This is the demolition of a manned gas holder. So the manned gas holders are well, there's none left in the country now, they're all gone. But there was one outside Battersea, Southall, there's a couple up in Liverpool. And these are basically 90-metre high, roughly, structures, about 60 metres in diameter. And inside them, there was a piston. And the low pressure gas was pumped in below them, the piston rises up, and then you close off the inlet valve, and that used to give you your low pressure gas supply for cities. When we moved towards high pressure gas mains, these things had to come down. And the way we do it is we pump the piston up to the roof level, cut the roof free, and we build these working platforms and crane systems here on top of the piston and on top of the floating working platform. And that floats on a bed of air and allows us to sequentially deconstruct the structures from the top to the bottom. Again, it's quite an interesting project, and one that we'd like to do a case study on in coming weeks if people are interested. And we come to more temporary works here. So you've got working platforms here for the SPMT to run on. You've got temporary stability propping. You've got a temporary beam support on top of that structure. You've got more propping over here. All sorts of things going on in this picture here. And then the left-hand picture, you've got facade retention, tower crane bases, temporary hoardings, scaffolds, all sorts of things that fall under the broad banner of temporary works. So many people you speak to see temporary works as almost something that people worry about too much. And I'm just going to kind of explain here why we worry about temporary works and why they have to be done, they have to be designed and installed properly. So if we go right back to 1909, I think this is Newport Docks. This is the aftermath of a large-scale earthworks failure. I think 38 people were killed. They don't actually know for sure because they didn't have good records of who was on site. But that's one of the earliest sort of temporary works failures that is recognised and identified as such. Then we come back up to the 60s, was this the 50s? Loddon Viaduct. So this is a structure just outside Reading. It was a new motorway, one bridge in each direction. And during the casting of this span here, the false work collapsed. I think there was 3 people killed in this one, and that was more by luck than anything. It just happened to be lunchtime, and they'd staggered the shifts, so half the workforce were off site having their lunch, and the other half were still on site. So if it'd been an hour or so later, you could have had a lot more deaths. This one is another classic temporary works failure. This is the M60 Barton Viaduct. There were actually 3 failures on this job. This was back in the 60s, I think. And there were 3 fatal incidents on this job. Again, quite a high profile failure. This was discussed in Houses of Parliament, this collapse. And then interestingly, you see in the background here, that is the M60 Barton Viaduct. And this was a new bridge that was being constructed in 2016, new lift bridge that collapsed during commissioning. One, we got called in to help come up with a system to stabilise it and get it out of the canal. It's a strange coincidence. There was 3 failures on this bridge, the old bridge being constructed, and then right next to it, crossing the same stretch of water, there was another failure. So 50s, 60s and 70s, there were quite a lot of accidents, incidents and collapses and deaths that led to the industry really taking note of temporary works and insisting that they were dealt with properly. The RAG report was produced, which included 27 recommendations, most of which have now made their way into 5975 in its various guises. The key ones that I've picked out are horizontal loads, looking at lateral stability, applying 3% as a horizontal load to formwork and false work structures. That's been down to 2.5% typically in 5975. Specifying lacing and bracing, making sure jack extensions are considered. The proprietary equipment has instructions. The systems in place for the management of temporary works. That's quite an important one, and that is quite a large part of BS 5975 is the management, the on-site management of temporary works. The importance of design briefs, again, that's still something that's really important today. Having a good brief that's detailed enough and gives you the information you need can make a big difference to how efficiently temporary works designs are produced. It also introduced the idea of a temporary works coordinator. Now, the temporary works coordinator is the on-site eyes and ears who's making sure that the temporary works design and has been managed properly, and that the temporary works have been erected properly. They're the ones who have to sign off the permits to load to say, yes, I'm happy it's been built as per the drawings. And say that all of that is within 5975. Now, we might have all of these procedures in place, but we're still getting collapses, which is why temporary works is still as important as ever, and making sure we have procedures in place and we do design properly. So here's just 4 that I've chosen examples of failures, temporary works failures. So you may all remember this one, the Florida bridge collapse, which I think was last year. Obviously this is in America, so they're not using our processes and standards, but it's still a temporary works failure nonetheless. If you haven't read the report the American authorities produced on the collapse of this structure, I strongly recommend you do. It shows a significant number of failings, both in the design and the execution on site. There were serious signs of distress with this structure. I mean, serious signs of distress 4, 5, 6 days before this collapsed. And it's real chilling to read the report and shows how people knew there was a problem but were unwilling to act. And it also shows the failings in the design, how people cut costs to and therefore cut scope out of their own design works, and it wasn't checked properly. There was no consideration at all of the temporary condition, which was really quite scary, given that it's clear just by looking at it, the temporary condition was far more onerous than the permanent condition. Gerrard's Cross back in 2005, this was precast arch units that were installed, and then they were backfilled either side to build a new Tesco's on top of it. Luckily, there were no trains passing at the time when this collapsed. However, that was purely luck again. There was a train that was just about to pull out the station at the time, but they saw the collapse, stopped and called the signaller and put the whole line on red signals. Unfortunately, that could have been a very different outcome if it had been a minute later. Nichols Highway again, this is America. A very, very large scale excavation collapsed. Again, there's papers online and presentations available online that show why the collapse occurred and make worthwhile reading for anybody who's interested in temporary works and failures and what we can learn from them. One of the key findings of this one was that there was no real independent checking of the temporary works design, which again in British practice is something that's set down quite clearly in BS 5975. And then we've got the most recent collapse here. So this is Didcot Power Station. Again, a structure that was being pre-weakened prior to blowdown when it collapsed. 4 people were killed in that one, and was a real eye-opener for the industry again, I think. So we've got all these procedures in place, but things are still going wrong. That's why it's important to keep up the pressure with temporary works and making sure things are done properly. Now, some of you will have seen this flowchart before, I am working on an update for the 2019 version of BS 5975, and Christian is smiling because he's been on at me for months to get this done, but other things get in the way, unfortunately. But there will be an update of this flowchart coming out to assist you all with the management of temporary works on site. But for now, I'm just going to run through the outline procedure because it hasn't really changed. What is different is obviously the clause numbers will be different, and there's more information within 2019 on all of these different roles, and they've also expanded on to kind of a larger scale sites where we have more than one TWC and how that interaction should be managed. So there's a lot more detail now within 5975 that suits the way that projects are being run in this country. But the basic flowchart and methodology doesn't change dramatically. So every organisation should have a DI, a designated individual. They are the person in the firing line, shall we say, in regards to temporary work. So they are the person who says whether someone's competent to be a TWC or to be a designer. It's generally going to be someone fairly senior of an engineering background who knows and understands temporary works. It's going to be a director of engineering or something along those lines. The DI will appoint everybody, so the TWC, the TWS, so TWC, temporary works coordinator, TWS, temporary works supervisor, who works and assists the TWC. On these bigger jobs, you can have a number of TWCs, but that kind of gets outside the scope of this simple flowchart. It's important that the TWC accepts the role and they accept it in writing, so there's a record that that they are the TWC and accept all the roles and responsibilities that come with it. The TWC prepares a temporary works register and which identifies all the temporary works required on the scheme. That's a live document. As projects develop, temporary works will be identified. They should be added onto the tracker. The TWC ensures that a brief is prepared for each item of temporary works. That doesn't mean they have to write the brief. That just means they have to make sure a brief is written for each item. And obviously the brief has to be suitable and sufficient for the level of complexity. So if you're on a greenfield site, an excavation might only be a Cat 0 or Cat 1 check. If it's in a city centre and it's adjacent to an existing structure and you're undermining the foundations, it might become a Cat 3 check. So it's kind of the onus is on the TWC and the designers to say that I think this needs a high level of check, and there is lots of guidance available on where things should sit in terms of risk and therefore checking level, but there's never one size fits all, and it relies on the competence of the TWC and the designers to say, I think you need to do a more independent check here, or I don't think this can be Cat 1, it needs to be Cat 2, or it needs to be Cat 3 because blah, 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 blah. Next one. So this is where we normally come in. Design brief is issued to the designer. Now, a design brief, writing a good design brief is an art. It needs to be detailed enough and it needs to have the information required for the designer, but it doesn't want to be too detailed in that you've told them exactly the solution you want, unless, of course, that's the way you like working. But generally, it should be, this is the problem, this is all the constraints, this is the information we have regarding the problem or the site. Can you give us a design that satisfies the brief? That makes it more interesting for a designer, certainly. But we do work with many clients who send in a brief where they've already decided what they want, and then it's just a case of putting some numbers to it for them. Both way works, but often you can get a more innovative design if you give us a bit more freedom. So once a design brief is issued, we then carry on with the design, produce the scheme drawings, and we'll provide design certificates, and we'll issue the package back to the TWC for review. If the TWC is happy with it or they've got any changes, then we'll make them, and then it goes off for design check. Obviously, for some items, if it's just being Cat 1 checked, it would probably come in as a Cat 1 checked package straight to the TWC. If it's going for a Cat 2 or a Cat 3 check, it's probably prudent to get the site team to review it sooner rather than later. to make sure that we've understood the brief and they're happy with the design. Oftentimes you find that people want to change the system that's being used. So they might have used, say for argument's sake, an R&D system, and they're struggling to get hold of it, or they've got a better price back from maybe. So at that stage, there might be a change to say we want to go with a different solution there. It's not uncommon at all. So then we have the design check. So design check, you've got category 0, 1, 2, 3. 0 the least onerous, cat 3 being the most onerous. For cat 2 and cat 3, the checker should not be seeing the designer's calculations at all. In fact, calculations no longer form part of the design output according to 5975/2019. But many clients are still insisting they're issued. But it's important that the cat 2 and cat 3 checker does not get to see the calculations. You'd be amazed at the number of times still we send off a package and then you get a load of comments back from someone who supposedly cat 3 checked your design, where they've looked at the calculations, or even worse, they've rerun the same calculations that you've done in the same piece of software. It's frightening still how some people consider a cat 2 and cat 3 check should be done. So once the check's done and everyone's agreed, because it's not inconceivable that the checker has a difference of opinion to the designer, and this should then be managed. So the checker should provide a list of comments back to the designer, and then a discussion could be undertaken to establish what's going to be done, and whether the design needs to change, or whether the designer and checker need to have a conversation and understand why the decisions are being taken. But there should be a record of that discussion. The whole thing then goes to TWC. TWC briefs the on-site supervision, ensuring they understand the design limits and the guidance notes that are on the drawing. If there's a note on the drawing that the designer has put there and it doesn't make sense to you, then the best thing you can do is ask a question. It could be the designer has spotted something you haven't, or it could be that the designer has misunderstood something that's on site. It's always best just to ask the question. In fact, one of the standard notes on our drawings is, if in doubt, ask. It's much easier to ask a question than make an assumption. Temporary works is put up, TWC goes out on site and checks it, or the TWS goes out on site and ensures that it has been erected as per the drawings. If there's a difference between the design and what's been constructed in reality, it is vital that you have a discussion with the designer and they accept the changes on site, or you make the changes that the designer requests to suit. Otherwise, the TWC is taking quite a high level of risk upon themselves. So once the permit to load has been signed off, the temporary works can be used, and then the temporary works should be inspected on a regular basis by a competent person. When the temporary works are no longer required, a permit to dismantle should be produced. Sometimes you'll find that the dismantling is as complex or is more complex than the erection of the temporary works. In fact, this is some learning that we've had from going back, I don't know, 5-6 years ago, that we need to pay, and everyone needs to pay as much attention to dismantling as they do to erection of temporary works. It's almost like you've done the design, they've put it up, and then they're in a rush to take it down. And that's when we've seen more accidents than with the erection of temporary works. It's quite an important one we've put on here, which is feedback to the designer and the site team. Often you'll find that the site team really like the design, or they didn't like the design. There's something they would like to be done differently in the future. If you tell us, we can take that on board. And there's nothing that I'd like more than to get feedback on our designs on a more regular basis as to how they've actually performed in reality, as opposed to on our computer screens and in our heads. Right. So this was just a brief introduction to temporary works and why it's important. If you want to know more, I can recommend nothing better than the Temporary Works Forum website, which is on the screen for you there, and BS 5975/2019. And Also, the Temporary Works Principles of Design and Construction, edited by Peter Pallett and Ray Phillip. That is kind of the Bible for temporary works and has a great deal of useful information. It won't tell you how to design everything, but it will tell you where to look and some of the pitfalls and issues to avoid. Right, we'll have a quick break there. Give my throat a rest for a minute. And is there any questions? I think I saw quite a few popping up, to be honest.
Yes, so we've got about 9 questions, Angus. So you've obviously hit some key topics there. So what I'm going to do is, we'll take a quick couple of seconds to, talk. Let you rest your throat, as you said, for a second. It can be quite daunting talking, but please do put any questions you've got in the Q&A section. And then what I intend to do is, if people are willing, I will unmute them and allow them to join the conversation so they can ask the question directly to Angus. We'll start with Mark in a couple of minutes. But yeah, I guess I'll just take this opportunity to say, didn't necessarily introduce myself fully at the beginning. I'm Christian Downer. I'm the Marketing and Business Development Manager at Andon. It'll be me that's sending emails about the upcoming events. As Angus says, we do intend to do these as a series. I know one of the meetings we're going to have today is just putting the final details on the next couple of weeks at the end of this, isn't it, Angus? Just to put that together. I know that we're going to be looking at temporary works, and we're also going to be looking at the temporary works and demolition is going to be a key piece, because some of the case studies, I know you talked about some of the key projects we've worked on in the last 12 months have been quite big demo projects, haven't they, Angus?
They have indeed, yeah. Which a lot of our work is demo. Right, should we give this a go then? So the first question is from Mark Nichols. Are you going to control it, Chris, or?
Yeah, let me see. I'm going to just see if I can bring Mark into the conversation. Hi, Mark. How are you doing?
I'm all right, mate. How's you?
I'm good. You've got a question for Angus?
Yeah, I got, 2 questions really. Number one, how far does temporary works go within the offshore oil industry? Obviously, you get big rig refits and all the rest of this. So does British Standard BS 5975 apply to the offshore oil industry? And the second one is, you said you have 2 ways of working when you get designs coming in. One is the client says, here's the problem, fix it. And the other one says, here's the problem, this is what you want to do, now give me the maths to go behind it. On the second option, is the client not actually taking part of the remit of the designer as well, because he's providing instruction on what he wants you to do?
Yeah, well, I'll answer the second one first. So as I see it, yes, the CDM regulations define the designer as he who makes a decision, or she who makes a decision. So if you come to us and you say, I want to do it with this proprietary ground system, or I want to use strong boys to take that wall out, you are taking an element of design responsibility. However, we've still got to validate that design, and if we find it doesn't work, we're not going to sign it off and let you carry on. Do you see what I mean? So although you're saying you want to do it like this, it doesn't mean it's possible. But if it is, and that was your idea, and the numbers back it up, then there's no reason why you need to be unduly worried about taking design responsibility. But legally speaking, I believe you are the designer.
Angus, before you hit question 1, we've actually got, you mentioned the book about temporary works. I believe we've actually got Ray Phillip, one of the authors on the call, and he's put in the chat that he was on the committee that wrote the standards, and that he believes the intention that offshore would be included in the temporary works.
Oh, that's great, because I didn't actually know the answer to that. My thoughts would be that even if it doesn't, the principle should still be applied, whether you use 5975 or not. The principles are sound and are there for good reason. But as to the legislation and how it works, I don't know. But as Ray has said, he believes it is, and that is the intention. So it might be better place than the man who was involved with writing it, I suppose.
Yeah, I'm just actually going to bring Ray in, because I think if that question is his area of expertise, if he's able to unmute and talk to us. Hi, Ray. How you doing?
Good morning. I'm fine. Thank you.
Fantastic. Do you want to maybe speak to this a little bit, seeing as, yeah, as Angus says, this is your domain?
Not sure about offshore as my domain, but the intention is the standard covers all forms of temporary works, be that onshore, offshore, whatever aspect you can find. And you're quite right in saying the principles should apply offshore as well as onshore. Obviously, offshore, the risks I would suggest are somewhat multiplied compared to doing a similar piece of work onshore. If you took scaffolding, for example, building a scaffold in a field is a relatively simple thing to do, or can be a simple thing to do. On an oil platform, it's not quite so simple.
Yeah, it's this thing we talked about earlier. It's something simple one place is not simple another. You've got to have a TWC who understands and a designer who understands the risks and what level of checking is required and how much input is required in the design. It's a very valid point.
Yeah, I mean, it was a leading question from my point of view, in that I obviously work for a company that has an offshore interest, and when I've spoken to the office that runs the offshore interest, they've mentioned another set of rules and regulations which they believe apply to the UK's offshore installations, not the temporary works that we would use under CDM onshore.
Right.
Okay, great. So no, thanks to Mark and Ray there. That's much appreciated. So the next question, I think this is quite a good question given the current situation. Angus,
Excuse me.
Rob, who asks about if you've done a temporary works for a 3-month project, it's installed and the project is put on hold for a year. You know, does it need to be checked and enhanced as permanent work? So again, I'm just going to allow Rob to talk if he's there. Hi, Rob.
Hi, Christian.
Hi, Rob.
Hi, Angus.
Morning, Rob.
Hi. Yeah. So I'm currently in a industry and got a couple of sites running on the principal contractor side, and as a result of the lockdown, you know, one or two of the sites has been put on hold. So obviously the question raises of, you know, what happens to the temporary works, because the design of the temporary works would be a certain period, but then there's no one knows when we're going to be able to go back there, particularly with the railway industry, where you have to wait for the next blockade or abnormal possession to be booked. And so it's always a question of, well, what do you do in that situation?
Yeah, I guess there's been some guidance produced by the TWF again on what to do in this situation. But from my perspective, where I've been asked this by clients, it depends on what it is. So if it's earth retaining solution, you could go from short-term loads to long-term. So from undrained to drained conditions, which could significantly change the loadings. That's potentially one issue. Then there's the wind loading issue. If you've been pushing it, shall we say, and you've designed a system that can only work in the summer months, i.e. you've applied the appropriate factors for the wind loading, seasonal adjustment factors, then you've got to look at it with a longer term wind load. Typically we design for a 2-year wind load, or for to be in place for 2 years, which I think is 1 in 50-year wind event. So as long as it's not going over 2 years, for the wind side of things, it shouldn't be a problem. I'd be more concerned about geotechnical, anything that's in the ground, large scale excavations, which were designed to be in the undrained conditions. Hopefully we're not in that situation where things get put on hold for that long, but you've made a valid point there about the rail side of things. If we can't get another possession for a year, it becomes an issue. But again, it comes down to you as a designer or a TWC looking at it and thinking, well, what's going to change in a year or a 2-year period that's going to affect the design? And it's got to be looked at on a case-by-case basis. But the best place to start, I would say, is a TWF guidance on that very subject.
Thank you.
No problem.
Fantastic. Brilliant. So the next question I have is Mark Doyle. And again, I'm just going to bring up Mark, and the question relates to, would you expect to see a design brief for a proprietary product, say platypus, ground anchors, or would manufacturer's instructions be deemed suitable? So Mark, bringing you in there if you're able to chat.
Hi guys.
Hi Mark.
Hi there. Yeah, so I've had a principal contractor in the past that has proposed the use of platypus ground anchors, and they suggested that a design brief wouldn't be required because they'd be following the manufacturer's guidance. Would you agree with that? I didn't agree with that. I said that a design brief would be required for the specific use that they were intended it. But what are your thoughts, please?
So, what the anchors being used to anchor? Was it sheet piles or was it onto some other retaining solution?
Well, these were, if you like, being used as lanyards. So wires were actually clipped onto them to actually prevent them falling off an exposed edge.
So that technically it's still temporary works. Now the level of detail required in the brief is probably the thing that I would look at. I would say they could do a very simple brief that says this platypus system is got to be used to provide full restraint, and therefore we consider it needs to be able to withstand a load of, I don't know, X kilonewtons.
Yep.
And it'd be as simple as that. I don't think you need to go into much more detail. Here's the ground conditions. Mr. Platypus anchors, can you give us a design that matches this criteria? They probably did it in emails. It's just people get this hang up about, oh, I've got to write a brief now. Whereas in reality, all you've got to actually do is an email can be a brief if it's a simple enough project.
Okay, cool. So literally just a one-liner email would be sufficient in terms of a design brief.
Yeah. I would have said so. Just if it's that level of risk that's involved, that's the way I would deal with it. And for simple jobs, we regularly just get a simple email that says, "Do this, please."
Okay.
So yeah, that's the way I would look at it.
That's brilliant. Thank you very much for your help.
No problem.
Thanks, Mark. Great. So the next question is a two-parter from Pete. So I'm going to try and bring Pete in. The first one around TW Works, temporary works guidance from the NFDC. Are you there, Pete?
Hi, how are you doing?
Good, thanks. So what's your question for Angus?
It's as my position as a freelance project manager, I work with a few different, in demolition, a few different consultants, and I had a conversation recently with one of the consultants that suggested that all demolition works was classed as temporary works and quoted the NFDC guidance, which I typed into the question, but I can't quite remember word for word. So is the interpretation of the NFDC that all works is at least class 2, category class 2 temporary works correct or not?
I would say again, it depends on what you're demolishing and where you're demolishing it.
Yeah,
it's not a one size fits all. None of this is the problem with standardising things. It's got to be open to reasonable interpretation by the TWC and the designer and everyone else involved in the project. For dismantling something, a house in a greenfield site, does that need a temporary works design or check? I don't believe it does. Does that taking down a simple shed in a greenfield site or where there's no adjoining properties, does that really need much? Personally, I don't think so. But if you're then coming into demolishing something in a city centre or where you've got adjacent properties or other constraints, or it's on a site which is live, so a refinery or something where you're taking down a simple structure within a dangerous location, then I don't necessarily disagree that it needs to be thought about, but it doesn't necessarily need a set of calculations per se. It can be done by someone competent who knows demolition and has demolished structures, knows how to take a structure apart.
My issue in this specific incident was it was a structure to be demolished on a gas refinery that was completely decommissioned. The work had been, the methods had been written by myself, so I'm not a structural engineer, but I'm a demolition engineer. Mm-hmm. The pre-weakening that we'd done had been underwritten by a structural engineer.
Yep.
But this chap was expecting the structural engineer's work to go away for third-party checking, even though it was very simple demolition technique of like a hinge cut on a column just to take over an elevation, which I thought was a bit heavy-handed. I can understand when there's full pre-weakening for a blowdown or a dismantling sequence where you might have to interpret what the load paths are. So yeah. I just think the NFDC guidance itself is just a bit of a broad brush and doesn't really help people making decisions on what is temporary works and what isn't.
Again, it's the problem with writing prescriptive things down. From your description of it, I would probably be in your shoes with what you're saying, and I'd agree with you that if it's a simple structure and it's just a couple of hinge cuts, does that really warrant a Cat 3 check? I don't think it does. I would have thought a Cat 2 would be more than adequate for that.
Yeah.
But again, it's about people understanding the difference between what they're specifying and when. It's easy to say get it Cat 3 checked. It's the easy option, isn't it?
Yeah. Okay. I think you've answered my second part of that question as well then. So thank you very much.
No problem.
Thanks, Pete. So Pete's actually opened the door into a few questions we've got, Angus, around Cat 3 checks.
Uh-huh.
I'm just, because I think they're all going to be rolled into one rather than bringing people in, I'm just going to summarise them. So one is from DM Tech saying that, they think there should be very few Cat 3 checks, as getting the same organisation to do the design and check is far easier to manage. I think that the BS Standard Committee thought that would be more innovative. So rather than necessarily getting into that as a whole conversation, because I think that's more structured be. So, when is a Cat 3 check required and what would the process be, which kind of brings in Edward Pugh as well, who asked that question in the chat.
I'm just trying to find that question.
So there's, in the chat, it's a little bit up about 10 minutes.
The chat, sorry, I was looking at the Q&A, not the chat.
So DM Tech asked it in the chat at 10:31, their question. And Edward Pugh asks about the process around Cat 3 checks in the chat about 10:31, sorry.
Please could you reiterate what you'd expect the process for a Cat 3 check to be? So I would expect the design to be completed, and then I would expect the drawings only and supporting information to be provided to the Cat 3 checker for them to undertake a Cat 3 check. It's okay to pass on a design statement that outlines how the designer has done the design, but not the actual physical numbers, as it were, the calculations. I would suggest, well, not I would suggest, that's what the guidance says. Cat 3 check is an independent set of calculations produced that verifies that the solution works. Hopefully that answers your question, Edward. Sorry. What else we got on there?
Yeah, I think on that one it was just as well, and I think it's possibly worth just going over again what you think the process around Cat 3 checks and when they're required. Is it possible just to overview that slightly?
Cat 3 checks are supposed to be for something that's novel and unusual. I would say they're overused by clients, particularly Network Rail, often insist on Cat 3 checks, where I don't necessarily think they are required. The only difference between a Cat 2 and a Cat 3 is that one is done by an external company. A Cat 2 could be undertaken and give you the same output. So, for instance, if we design something in the Chelmsford office, the Cat 2 will be undertaken by the Scottish or the Midlands office. So you've still got that level of independence between the design and the check, which is, after all, that's what you're trying to achieve. You're trying to make sure that the designer or the checker is not being led by the designer. They're making their own independent assessment of the design and whether it works or not. I've got another question there.
So we've got one from Martina, which I will try and bring. Martina.
Just before we do that, I just kind of think we might want to finish the presentation, then deal with all the answers afterwards, because there seems to be quite a lot left to get through, and I'm conscious that we're going to be eating up more and more people's time
Okay, no problem. That makes good sense.
The
So
right people, and then anyone who wants the question answered at the end, I'm quite happy to spend some time. I just don't want to. I don't necessarily want people to everyone to be sitting there waiting for these questions to be answered. I mean, unless anyone's got any real objection to that, I'd rather get on with the presentation than answer the rest of these. To be honest, we've got a lot more questions than I thought we were going to get. So,
so I think that's a sensible way. We'll get to the questions at the end, and that way we can get to the main part of the content. And people that want to stay on and ask questions will kind of stay until we're done. But that way, if people want to leave and get on with their days, then they're not sat listening to us talk.
Right, so this is a case study. Again, some of you may have seen this at the Temporary Works Forum 3 years ago or something like that, but it's quite an interesting little case study, and we'll go through it again. So, Manor Park Station walkway demolition. So the key people, Hot Teeth for the principal contractor, we were the engineers for the Temporary Works of demolition. Kilnbridge did the actual demolition, King Lifting supplied the cranes, and then the stakeholders were London Overground, Network Rail, Crossrail, and the Newham Borough. What we had to do was demolish this structure here. Okay, so this is on the Great Eastern Main Line coming out of Liverpool Street towards Chelmsford and up towards Ipswich. And this is Manor Park Station. You won't recognise this now if you go to Manor Park Station, because there's a shiny new bridge in its place to replace this old, tired-looking structure. So there are a lot of constraints on this project. One of the key ones being the OLE. Now, the OLE system was quite an old system, and to raise and lower it posed quite a lot of potential risks to the client because of the age of it. There was potential for things to fail when it was being raised and lowered, so we just kind of, that was one of the drivers as to why we went down the route that we did. That's a view looking out from the footbridge towards the station, so you can see the proximity to the OLE and the return conductors. This is the electrics, that's the mains over there, then there's also an avoiding loop going around the far side there. Another key driver was the distance to the RAP. So the RAP is the road rail access point. It was quite a long way, 160 metres from the closest RAP to the bridge, which would mean getting large excavators down there would be quite tricky. The possession schedule as well made things difficult with the amount of time we had available. We had quite a lot of possessions, but they were often, we would get the electrics, which are these lines, before we get the mains, which make things quite difficult when you're trying to demolish a structure here that comes up on an island platform between the two. So this is a markup of the original drawings. You've got the structure coming down onto the island platform, and then we've got this raised walkway. So we identified it, we could take it out in 3 sections, section 1, 2 and 3. It's quite an interesting construction. You had concrete encased steel beams, then you had precast floor planks, masonry walls, precast roof planks, and with an in situ concrete capping beam. So it was not the sort of structure you typically lift out. Originally built in 1949. So we decided that the best thing we could do was, as I said, cut and lift it out. Given the constraints and the time we had available, would be to cut it and lift it into pieces. So the first problem you've got is, where do we put the crane? The only possible position for the crane was in the adjacent road, and it was very, very tight. You can see here the back of the footpath, so the road front of the building is just there, which meant that the other outrigger was going to be sitting behind the wall or very close to the wall. Putting a large outrigger load behind a masonry retaining wall is never a great idea if you can avoid it. So we came up with a solution where we placed the outrigger directly over the top of the wall, which thereby makes it a stabilising load. If you build a tower of wooden blocks, they're very easy to push over. If you build a tower of wooden blocks and you put a load on top of it, they become very difficult to push over. And that's exactly the principle we used here to demonstrate that the wall itself was stable and this load is beneficial. And because of the way the wall was constructed, we were quite happy that there was sufficient load spread at the base of the wall that this 165 ton outrigger load at the top here wouldn't cause any bearing failure. So we designed these beams that went on the top. Now the reason they're so long, given the masonry wall, is the need to, I've just gone wrong there, sorry. The construction of the wall was such that there were joints at regular centres along it, so we weren't sure that we could spread the load along it. So that's why we put a steel beam on the top here, with the outrigger in the middle here. That thereby ensured we mobilised sufficient length of the wall that we'd be sure that we weren't overloading the wall in bearing. It was delivered to site with this hand railing system already installed, because as it's installed, we had to take out part of the masonry wall here. So this handrail system was built in as part of the support. So you had no edge protection issues, no open edges from the very beginning. It also had bases here to allow us to prop the wall. Where you cut through a masonry wall and create a new end, you can artificially increase the wind loading. So as a belt and braces, we designed the system to allow us to prop the wall at the same time and give us edge protection. So that's a good example of designing out a hazard in a quite simple manner. I said it was tight. This is a 3D model we used. So that purple cone there shows you the outrigger swept path, as it were, and then the backstay swept path is in that cone there. So this lamppost was very, very close. There's also that cone there which represents the tree. The counterweights actually went underneath it. You can't see there how close it was to the buildings as well, but when I say only just fit, I mean only just fit. So we figured out where we can put the crane. Now, how do we come up with a solution that allows us to take this structure out? Now, one of the key concerns from an early stage with the client was they wanted a solution, a demolition system that could be stopped at any point. So if we ran out of time, that the railway could reopen. So we had to come up with a propping solution that would support the structure in place even when it was completely cut free and allow the trains to run again. So what we did, we used the self-weight of the structure that goes down these piers here, and almost like a seesaw arrangement here to support this span here, which is going to be cut out, and the same on the other side. So we got a beam that went under each end there in green, there, and then that's picked up by a pair of super slims there and a pair of super slims there that take it back and down the structure and restrain it, so we could cut the whole thing free, and it would sit there on those temporary supports until we lifted it out of the crane. You can see there in more detail, we've got this steel beam that sits underneath, and we performed a sit cut in the rear and the bottom beam, ready to lift it out. And you can see the strap that returns back down and picks up on the pier and gives us the reaction force we require to support that span there. Interestingly, you'll see that if you overlay the temporary works clearance gauge, the structure was already within it and everything else was just about outside it, which made life simpler. So the detail of the packing. So where we did a sit cut in the beam, because we had to have the potential for it to sit there for a week with the railway open. It went wrong in the first possession. We put a proper bearing back in. So we cored out 4-5 core holes, and then we formed a little bearing within there by grouting some steel plates in, and then we finished the saw cuts so it could actually sit there properly on a bearing, and we knew where the load was being applied, which is directly above the steel beam there that supports the span in place. That's one of the steel beams that was lifted up underneath to support the bridge. So I think I mentioned earlier that in the possessions we would sometimes get the electrics but not the mains, or we'd get the mains and not the electrics. So we wanted to try and use the possessions as much as we could. So we came up with a system where we could do most of the pre-cutting, in fact all the pre-cutting of the structure in a preceding possession. So when we came to the possession where we were going to lift it out, we literally had to sling it and lift it. As it turns out, that's not what happened, but the plans and the approvals were all in place to allow that to happen. We also put in temporary restraints for the other 2 spans that went back down the structure, and planned to use the same basic principle on the other 2 pieces that had to be lifted out. And then the steps and that last pier were just demolished piecemeal in situ with Brock. So we made good use of the 3D model for clash detection and making sure that everything fit first time. Everything was planned in 3D and designed in 3D to make sure it fit. A point cloud model of the station was provided by our client Hopteeth that we used for all of this, and it identified where there were clashes, and we put things in place to make sure that that was eliminated and that everything would fit first time when we got to site, and as it turns out it did. This reassured Network Rail and Crossrail that it could be done the way we said it was going to be done. So the actual lifting arrangement itself, given how this structure was built originally, you've got concrete encased steel beams, and you've got precast floor planks, masonry, in situ capping beam there, and then a precast roof plank. We wanted to make sure the structure was going to stay stable in the air. So we put timber frames inside, and we had this steel lifting frame that came up underneath it, gave us defined lifting points, and actually clamped onto the beams at the base there and supported the masonry, just to make sure that there were no problems. Again, all done in 3D to make sure that it would fit the final structure. And there it is in place. So got the 500-ton crane, 4-point lift with chain hoists to provide any final adjustment to balance the load out. So just if you go back to that picture there, you'll see the OLE remains in place. We didn't drop that. We slewed it slightly just here. And that made it quite challenging just to get the lifting gear in place. You've got a mass of cables in the air. We had to make sure we could get the lifting gear down onto the track and then up in the right position and slung ready to go. So even that was planned out fully to make sure that we could do what we all intended to do. There's one of the frames being lifted into position on the night of the first lift, and then Kilnbridge get to work with their saw cutting to finally free up the bridge. You can see wire sawing there of the slab, and track sawing of the roof slab to release it, ready to go. Lift beams in place on temporary track protection formed from plywood. And at this point, we could breathe a sigh of relief when the span first lifted off. It wasn't without its little teething problems, just getting enough clearance to get it out, and it wasn't slung quite right, so it was hanging at a slight angle, but they got it out with the help of a few people on some tag lines. And I say at that point we could breathe a sigh of relief as the first span was released. Once that one was gone, the other two were a lot simpler. I say that, but I know we've at least got one person on here from Hopteeth, and they might tell you a different story. But we were on site throughout this, providing site supervision on shifts with the client to make sure everything went as planned. And all honesty, it went really well, really well. So this is a little time lapse of it being done. So you can see it's been cut through up there, released fully. Temporary props gone in over there, was about to go in over there to the wall just in case we knock this as we're lifting this span out. First lifting frame in, second lifting frame in, carefully hidden behind this pole. And there you go, first span up and away, and it's time to tidy up. When it was lifted out, it was sat up on the road, and then it was demolished using machines with breakers, as you would do any normal demolition. There's just a few more pictures of it actually in the air. It was quite a sight to see that crane sat there with that 70-ton lump of bridge hanging off it. And there you go, you can see the structure sitting on some prepared packers up on the road, ready to be demolished. So this actually shows you quite clearly the temporary works that are in place to support it. There's the steel beam that was lifted up, and there's the two super slims that tie back to these divvy dags here and down back to the pier. Quite a neat little scheme that worked very well and allowed us to stop at any point and reopen the railway. Span 2 and 3 were a lot simpler because you had a free end, and there was no real propping required. We had one beam up here, and then it was just cut free and lifted out. So I've rushed through that a little bit, conscious that we're overrunning now. We said we were going to take, but in conclusion, it was an innovative approach that paid dividends compared to doing traditional methods. And it was delivered on time and budget, and all the stakeholders considered it to be a great success. Interestingly, it took quite a lot of persuasion of the stakeholders initially to consider it as an option. Took an awful lot of work, quite a lot of meetings and 3D models and sketches and bits and pieces to persuade them that it was indeed the correct solution. But they let us do it, and we went. Okay, so if there's any questions there, but we'll just finish the presentation, then we'll drop back to the questions if that's okay with everyone. So we are talking about, or we're planning on making this a weekly event, where we'll follow a similar format. There'll be a topic, there'll be a case study. We're talking about having some guest presenters, and there'll be some other engineers from Andon who will get involved and present case studies of projects they've been involved with or responsible for the business. Just to whet your appetite slightly there, we're considering the following options. So we've got pull downs and blow downs, temporary works for demolition, temporary works in a rail environment. We're going to have a guest presentation from Malachy, from Alan White. Although they're a competitor of ours, they're also friends, so they're going to get involved in the action and give presentations to anybody who wants to sit there for an hour and listen. The Churchill Way flyover, I'm going to present that. Waterloo Station redevelopment, gas holder demolition. We talked earlier about gas holders briefly, but there's some really interesting engineering involved in those. For those of you who dislike Tottenham Hotspur, you can see how we work with DSM to demolish the Spurs ground. In fact, as a little sneak peek, there is the truss that we dropped from about 50 metres up in the air, just to give you an idea of how big that truss is. There's Birmingham New Street redevelopment, which again you've seen some initial photos of that give you an idea of the temporary works and engineering that went into that. There's Willesden for HS2 crane pull down, which has got some interesting videos. Basement temporary works, and then I think quite a good one is the checking of temporary works. Quite a lot of people have asked questions about that today, and we're proposing to give a bit of a presentation on what good checking is, what a checker should do, and running through what checking, what a Cat 1, Cat 2, Cat 3 check actually means to you. So I hope you've all enjoyed that today, and if anyone is still listening and wants to go over the questions, then I will finish off answering any questions that we have. And if anyone's any more questions regarding the presentation on low cross I just gave, then feel free.
That's great. So I would just say as well, you know, if you're hungry to see some of those case studies before we do a presentation on them, we have a whole range of case studies up on the Andon website. You know, I know Churchill Way has just been put up, saying, you know, and just go andon.co.uk. You can see all the case studies there. We are going to run through the questions, but if you do have any projects coming up, or even just questions that you think might be more appropriate offline than on a webinar, please do reach out to myself or Angus on LinkedIn. I will put his LinkedIn profile link on the in the chat, and just get in touch. Same with other CPD that you think might apply to your organisation. And Angus warned me not to do a sales pitch, so I will stop there. It's the business development in me, Angus. So we can pivot now back to some questions. And yeah, I think we're going to look at the first one I'm going to address because it's a simple one. We've been asked about presentation slides and the videos and recordings. Because this is, an hour long's worth of video, and the slides we'll look at, one of the conversations I have with Angus will be the best way we can share that with you, because obviously if it's a huge file, that might not be something that's easy to do, but we'll figure out the best way to do that. And because you've registered with your email, I will share the plan with you all. And I guess the next question, I will just check if people are still in the room, if we bring them on or not. But we've been asked by someone, do you recommend any resources for good templates examples for a design brief?
I think that was Chris, wasn't it? Chris Plant. Yeah, I was speaking to Chris earlier on the phone. Assuming it's the same Chris Plant anyway. The best bet, again, is the TWF, Temporary Works Forum. I'm not sure if they're accessible for everybody. I'm pretty sure they are. I think there's a set of outline procedures for businesses to use on there that has examples of briefs, of registers, everything else. But if you can't find it, drop us an email and I'll point you in the right direction. But honestly, the Temporary Works Forum is a very, very good place to start for any interest you have in temporary works. I don't know, is David Thomas still on? He might be able to answer the question as to whether it's on there. There you go, free for all. He has answered the question.
TWF guidance is free for all. So yeah, you can just put TWF or Temporary Works Forum into Google. That pops up first result and pull you in the right direction there. So we had a question from.
There you go. Maliki said basically the same thing. There's a Word version on there as well, so you can take it and tweak it yourself. I know I've certainly passed that on to a number of clients who've asked me the same question. There's no point reinventing the wheel when somebody's already done the hard work for you.
Okay, so let's have a look through questions again. Let's see, I'm just seeing if these people are in the room. So Martina's still in the room. She asked, will the appointment of a TWC and a TWS depend on the size of a project and complexity of the temporary works? If we have scaffolding hoardings and some shallow excavations, do we need to appoint a TWC and TWS? I'm just going to allow Martina to talk. So if she is there, she'll be able to join in the conversation. Hi, Martina.
Hi. Thank you very much. I'm getting involved in many smaller scale projects where very often, I'm a principal designer on these projects. Very often we have some scaffoldings or crane lifts, bespoke or TG 2013 compliant. Would you say that temporary works coordinated temporary works supervisors are required? What is your advice on that?
I think the guidance is quite clear that all sites should have, where there's temporary works involved, should have a TWC. Now, the level of experience and competence of the TWC is obviously has to be tailored to the job they're doing. So if it's a simple job with just some basic scaffolding and basic hoarding, then the skill set the TWC requires is not that high. Whereas if it's on, I don't know, a complex job in London, or I say London or any other city centre, with multitudes of temporary works involved, then you will definitely TWC. You might need a TWS to stop the TWC being overloaded, and the competence required of the TWC will be much greater. There's been interesting discussions on the Temporary Works Forum related to this. What's Ray saying? There you go. Ray says the same thing. All sites should have a TWC, and they could be visiting, which is again is a valid point. You don't have to be there full time. They could go and look at quite a few sites.
Sorry, can I just have a follow-up question? When the contractor actually states that the site manager is going to undertake the TWC role, is this something that, with regards to scaffolding, for example, is that allowed, or is his competency enough then?
Sorry, would you mind repeating that, Martina? I was reading something that Ray.
If the principal contractor states that the site manager is going to undertake the TWC role?
Yeah, okay. So this is where we're talking about the conflict of interest, and it's quite a real topic. As long as they are still making decisions based on safety, not just on program and cost. So they have to do their job properly, basically. And I think that's what Ray's saying there. It's okay as long as they're competent to do so and they're not under undue pressure to keep the job moving. They can stop and say yes. I feel a bit bad talking about this. It's not my area of expertise, whereas Ray is it is Ray's area of expertise. So I'll keep an eye on the chat.
Okay, thank you very much for that.
No problem.
Yeah, Angus, I'm just going to bring in Francis, who asked a very similar question. Just check that we've kind of covered that one, because he asked, what's your view on the level of knowledge an individual should have relating to temporary works in order to be appointed by their DI as the TWC? Hi, Francis.
Hello?
Hi, Francis.
Oh, hi. Yeah. Sorry. And exactly that's what it is. And I think David Thomas, Maliki, and Ray Phillip know me quite well. I've been quite involved with temporary works for a number of years now. But I find increasingly, and it's probably leading on from the question Martina asked, I find increasingly that I come across sites where they kind of say, well, the site manager is going to be the TWC. And for me, as a DI, I've had the people who've been on a course, they then send me their CV and their certificate to be appointed as a TWC. I have a conversation with them and I find out that they don't know anything about temporary works whatsoever. But because they're a site manager, somebody said, well, you can be appointed as TWC. And it's something that I often grapple with. And it's hence why I've consistently raised that question, and I hope that those who are on here will also be able to take it back to their businesses and get the understanding a bit more. But it's something that I lose sleep over, because as a DI, I'm ultimately responsible for ensuring that the people I appoint are competent, and that means me determining what their competence is, and not some director who sits above me deciding that because they're a site manager or project manager, that makes them competent. And that's, I guess that's what I want to find out from you, Angus, and perhaps several people on here, what their view is.
My view is they have to be competent, and it depends on what they're involved with. If it's a very, very difficult one to answer, I think. Again, if you're on a greenfield site and you're using proprietary items, then the TWC doesn't need to be as experienced as someone else who's checking items that have been Cat 3 checked, so they're unusual, they're unique in their design. I have a degree of sympathy with the DIs who've got to approve these TWCs and TWSs, because there's commercial pressures and there's also the pressures, the safety pressures, and the fact that when you sign and say someone's competent, you've got to be damn sure they're competent. It's tricky, and it's got to be on a case-by-case basis. And again, it's not really my area of expertise as to how you go about answering that. But I have a lot of sympathy with you as to how the decisions you've got to make.
Yeah, Angus, what I think we should do on this one is, this might be a potential topic where we can bring in experts in the future as a separate conversation, because I think that there's obviously lots to discuss here and lots of questions about that. So we'll knock our heads together, after this one and look at that as potential, because I think that would be something to cover separately. Okay, brilliant. So I'm going to crack on this couple of questions. We still have over 120 people on the call listening to the questions. So
well, that's the benefit of lockdown. The only one is they can't go anywhere. They can't go far anyway.
No, exactly. So we've got one from, let's see if Robert's still in the room. Yes, he is. I'm going to bring, sorry guys, I'm just going to do a little bit of admin whilst, to make things a little bit easier. I'm going to bring Robert in. He's asking about scaffolding collapses. Are you there, Robert? see if he's able to join the chat. He might not be able. Ah, there we go. Hi, Robert. Are you there?
No, okay, well, I'll read it out then. So he's saying there's been a spate of scaffolding collapses associated with demolition of structures, which in my belief were based on wholly misplaced reliance on the ability of the scaffold to act as some sort of buffer to control and or retain debris falling collapsing as part of the machine process. Surely temporary works either wasn't being applied to the process or something in the temporary works process was wholly incorrect. Yes, there have been quite a few collapses. I haven't seen any reports on them, but from what I've seen, it's as Rob has suggested there, it's collapse of the structure has caused the scaffold to then fall over and fall in the street. I don't know that for sure, but that's my suspicion with what I've seen from the photos and the evidence that's available in the public domain. And this comes back to that same question: is scaffold really an adequate system to prevent a building collapsing if something goes wrong when you're demolishing it? No, it's probably not. But there are things that can be done, and in a lot of cases, it's driven by the client request to have a scaffold around a structure that's demolished to help control dust and things like that. What has to be planned is how the demolition is going to be undertaken with the scaffold in place. So if you look at it from the scaffold designer's point of view, they're providing a scaffold that is there for dust and to prevent dust leaving the site and provide access to the structure if required. Now, there's no way you can design a scaffold that's going to stop a building collapsing, because the scaffold relies on the building for stability. So if the structure falls into the scaffold's only going to go one way. What they can do is limit the effect. So if you're looking at temporary works, the yellow temporary works book, you'll see within there, there's a chapter I've written on temporary works for demolition, and it talks about scaffolds. Where they are to be used, you've got to make sure that tubes aren't projecting into the structure. That's one key issue. And you've got to make sure that the scaffold is designed to cantilever at least one lift past the level of the structure you're demolishing, because that's two cases that are commonly missed with scaffold designs. Now the question of, is it the right way of preventing the collapse? No, a scaffold's not. So the demolition has got to be planned and undertaken in a way that the scaffold is not being relied upon to stop the structure collapsing. So it's going to take a bit of a step change in the industry, I think, to stop putting scaffolds up. There is a solution I've seen from our demolition. They've got a system where they put up, they used on the Broadmarsh Centre, a car park in Nottingham near the Broadmarsh Centre, where they have a large scale cantilevering steel frame that sits on the ground with cartilage at the base and has timber protection down the face. And that they then move that along the structure, and that will prevent any rubble leaving the site. Well, that's the proposal anyway. I've not been involved with the design or anything, but I've seen it at a Institution of Demolition Engineers presentation. So if you have a look on AR Demolition's website, you'll see one possible solution. But I think scaffolding around buildings when they're being demolished is here to stay for a while at least. So it's down to the demolition contractor and those planning the demolition to make sure that the structure can be demolished in a safe means with the scaffold in place. And if they can't, then they need to come up with another solution. But a scaffold can never be relied upon to prevent a building collapse. Hopefully that answers the question, or at least gives you my thoughts on the question anyway.
Yeah, Robert just confirmed that, yeah, he could hear us, but couldn't be heard. So I think it's just a microphone issue. But yeah, no, so we're working through it. And Robert says, yes, that confirms what he was thinking. So we've got, we're piling through these questions. There's a couple left. So we've got Kilburn asks about data centers and responsibility for temporary works. That looks like maybe a slightly more complicated issue, Angus.
Yeah, I'm just reading it.
Yeah.
They are interfacing with occasion PC. So if I'm reading it right, what they're suggesting is they work on a data center. I don't suppose the site actually makes much difference, but the PC is trying to force onto them looking after the temporary works. I'm not sure if that's erecting them, designing them, or whether it's loading them. Are you bringing Kilburn in maybe to give us some?
Yeah, let's see if he's there. Or she is there. I don't know what I don't know who the name would be on that one. Are you there? Hello.
Hi, how are you, gents?
Not too bad.
We're good. We're good.
No, look, I tell you what it is. On the large scale data center constructions, what you have, you've got a main PC working directly for the client, just the same as most contractors. Well, we will come in standalone to build the backup generation set. Right? Normal thing, the main contractor will be in charge of the site, health and safety policies, procedures, temporary works, lifting procedures, all of that. We fully comply. We have to submit our risk assessment, method statements, our lifting plans 14 days in advance of any works going on. Accept it, not a problem. The only problem is when we come down to the slab, the only thing we're doing is lifting in our generators and putting them on and then connecting them to the interfaces. While at the same time, the PC is carrying on his works. Now, all the temporary works, the bracing, the excavations, the trenching, that is all his works. That's nothing to do with us. But yet they're trying to say anything within our slab will come underneath our temporary works design and our temporary works control. Well, surely that's not right.
Again, this is going outside my area of expertise. I think Ray has jumped in again. Thank you, Ray. PC always has the ultimate responsibility. But
correct. That's my understanding of the CDM regulations.
That is what I would suggest, is that that's what it says, and it's what your contract says as well.
Correct.
Yeah. And it's very, very unreasonable to try and make out that you've got to come in and deal with it all. But I can't. There's not a great deal I can add to that.
Nope, gentlemen, just that's my understanding of it too. And as long as we're in the same hymn sheet, I'm more than happy to fight my corner. Thank you very much.
No problem.
Fantastic, thank you. Yeah, so the next question, DM Techs, who have been quite, obviously work quite in the industry. How can we better allow organisations to plan and cost temporary works during the tender? What's costed is always different from what's required on site. As a trainer, I've developed a design brief exercise, and every person in the course will say they never cost for everything that needs to be included.
The best answer to that is to engage with the temporary works designer at an early stage. We do quite a lot of work at tender stage with clients to come up with solutions and give budget costs for things. That is the best solution. You'll often find that we can come up with ways that will help you win the tender even and save you costs. So the best thing you can do is engage with someone at an early stage and try and work out what temporary works will be required. But I know it's always the same, that the temporary work gets forgotten when people are pricing jobs.
Great, and then this is the final question. Whose responsibility is it to appoint the designated individual?
It's senior directors, I believe, isn't it? I think it has to be agreed who the DI is going to be, and again, they've got to be competent to be the DI. I can't remember off the top of my head exactly what the wording is in 5975, but it's a DI is a senior person within an organisation, and they'll be appointed by the board, I would suggest, generally. Oh, I'm sure Ray will probably put me right in about 2 seconds as to who appoints the DI. There we go, i.e. the board. There we go. Look at that. I didn't even have to read his answer this time. Thank you very much, Ray.
I think, so that's all the questions. I think it's been great as a first exercise. One, just to understand what's going through people's heads as well. I think we've identified some areas as we've got the slide up on the front there, plan for the following weeks. I think we'll be looking at some of the ideas that have come out of today to reinforce some of the points that have been raised. But no, we still have, as I said, 100 people on the call. So I want to thank everyone who has joined us today, everyone who has stuck it out to the end. Ray, Maliki, David, and some of the other people working, experts and people working in temporary works that have shared their insights with us as well. And yeah, thanks to you, Angus, for sharing your knowledge.
No problem. Thank you
Brilliant.
very much. If you're still there, Ray, is he still in the room?
I believe he is, yeah.
Let's see if he fancies doing a presentation. Would you fancy doing a presentation on the procedural control, your area of expertise, as a guest presenter?
He says not a problem. Fantastic.
I think you'll get quite a lot of interest. All right, well, we'll have a chat with you afterwards then, and we'll sort something out from there then, Ray. Thank you very much.
Brilliant. Thanks everyone for coming. Yeah, please do feel free to email me any feedback you have. Don't copy Angus in so I can vet it first, and if you need anything else, give us a shout. Thanks everyone. Have a great day. Bye bye.
Bye bye.